Okay, now a lot of questions on the Regents like to have us compare functions in different types. So this question here asks us which quadratic function has the smallest minimum value. Now, the first thing that I should be thinking is where do I find the minimum or the maximum value for a quadratic function? Is we always find that at the vertex. Okay, so what I'm tasked with doing here is figuring out what is the vertex for each of these quadratic functions. And then when they're talking about like the smallest or the largest, is we're really focusing on just the y value of our vertex. So easiest one to look at first would be the graph. Okay, so my vertex for j of x, that turning point is right here. That has a y value of 0. So that's my starting point. Okay. Now, if I'm looking at all of these others here, okay, I might say, what's the next easiest? Visually, I like to go with tables. So again, to find my vertex, symmetry. Okay. So 6 and 6, 2 and 2, 0 and 0. So for this one, I can't see the vertex exactly, but what I do know is that the vertex is going to be in between these 2 points. Okay. Now, further, what I can tell is that these values are decreasing, right? 6 down to 2, down to 0. So the vertex for number 2 is going to be less than 0. Okay. It's something negative. So right now, if I had to choose, I know that the vertex for 2 is smaller than the vertex for 4. So I know it's not 4. Now I have to try and see between number 1 and number 3, which of these guys here have a vertex that is less than this here. Okay. Now, first off is I know this one over here for g of x is in fact written in vertex form. Okay. Now, again, with vertex form, it looks like a times x minus h squared plus k. So analyzing the function here, I've got minus and minus. So this happens at 2 minus 2 plus k negative 2. Okay, again, the x coordinate comes from here. The y coordinate comes from here. So this has a vertex of 2, negative 2. Okay, so my vertex here, negative 2, okay, is going to be lower than this vertex here. Okay, now this part here might be a little bit subtle. Okay, but what I can tell is that the way that quadratic functions work is this drops from 6 to 2. I'm subtracting 2. So even if I know that this here is negative, I know it's not going to go as far down as negative 2. So g of x is definitely going to have a lower vertex. So right now, this here is my answer, but what I do need to check is for 1. Okay. Now I've got a problem with f of x here. Okay. Is that this is written in standard form. Standard form shows me the y-intercept. Okay. So I know my y-intercept is at negative 2, but I'm not sure about where my vertex is. Now, there are ways to take this function here, convert it into vertex form, but honestly, the easiest thing to do at this point would be to take this function, graph it, identify its vertex from there. So 6x squared plus 5x minus 2. Okay, I'm going to graph that. 6x squared plus 5x minus 2. Take a look at the graph. Identify the vertex. It's hard to tell here. So again, I'm going to look at that table. Okay, and let's see if I can't find that vertex. Okay, now this one here, it's hard to see the actual symmetry. Okay, and that's going to be because my intercepts don't occur at whole number of values. Okay, now that doesn't mean that it's not quadratic. Okay, that means that I might have to try to find that vertex a different way. Okay, but visually, if I look here, I could see -1, -2. That vertex appears to be down at -3. Okay, so if I want to, there's actually a function here under calc. Okay, if I hit second and then trace, okay, I can look down. That is a minimum value. Okay, so I just need to go to the left of that function. I need to go to the right of that point. My guess is over here, and I can see that y value is at negative 3.04. Okay, these are the exact coordinates of my vertex. So my vertex here is at negative 3.04. So this here is going to end up being the function with the smallest minimum value, number one. Okay, again, for this one here, we said that this one was going to be at -2. This one here was at 0. And this one here was somewhere just below 0. Okay. And that is how I would analyze that question there. But again, the key thing to remember is that when we're looking for a minimum value or a maximum value, is we're trying to analyze and find what is the vertex of that quadratic function.